Okay, so I'm gonna continue where I left off with. So I think I was here in the delete method. And I think I was about to test something, but don't remember exactly. Okay, but yeah, I think I finished implementing this delete method here. And I was saying like, okay, if there's no slot at this new offset location, of course it doesn't, like the thing that we want to delete does not exist. And if there's data and the key matches the key and deleted is false, well, we're gonna mark this as deleted, decrement, or actually this is technically not true. This is technically not true because we're not removing the element. So in fact, I do want to be able to print this thing. So I kind of want to search. Yeah, I'm gonna remove this thing from my screen here. Okay. Ew. God, I hate this thing. Really annoying. Okay. So let me print list which contains Python classes and same. You want just to print the label for each other, you could use a loop or a list. Yeah, that's what I didn't want to do. If you want to print the label for each other, you could use a loop or a list comprehension, but once because you need to define to get the list output right. Well, okay, let's test this. Let's test this and see if it works. No, let me say. Okay, cool. Yep, that was it. Perfect. Okay, now we have this. So now I am going to, I kind of, there's another thing I also need to do. So I mean, I could either keep doing the test like this, but okay, just for now, so it's quick. I'm gonna try to say lookup.delete, and I'm gonna delete key 25. And of course, key 25 doesn't exist. This should return. Oops, this should return false. So this should return false. So let's try, run this thing. Cool, working as expected, because of course key 25 doesn't exist. So now I want to delete key 5. So this should return true. And I also want to like print the thing here. Is true. So main.py. And okay, that's nice. So let's say key 5 is deleted true. Okay, cool. So that is true. But I want to test as well this thing here that I want to delete key 10 and then search for key 3. So let's delete key 10. And then I want to also search for this thing. So search for key 3. And then the value, of course, should be A, but okay, R does not equal none. So Perfect. So that worked. That's really good. So I just tested this scenario here. So I think this is actually it. I think this method should basically not be here. And then of course there's still the resize thing. So one thing maybe that would be interesting to do is, this is a little messy. So perhaps I mean, I can either use the native Python, thing to test, or I could use some framework like PyTest. The only thing is that for that I'll have to like install PyTest and activate and create the virtual environment and all of that. But I mean, I could do that. So I can just use pip. But the thing is that I forgot what's the command to do this in Windows. So Python, Windows, create virtual environment, CLI. Python 3 MVMV virtual environment. Okay, module load source. Okay. So let's do this. So I'm gonna just call it Python 3. So I already have Python 3 installed here by default. But I can say Python 3 m and then the name. So I can just call it m. And before that, env, I think here. Env perhaps. Okay, so I have my env. Okay, perfect. This is it. And I also think we'll need to commit here. I'll do it in a sec. Okay, and then to activate it, so I will say env, think env, and then I always also forget how to do this in Windows. Env scripts activate, I think scripts, and then activate.ps1, that's the PowerShell script. So activate ps1, activate.ps1. No such file or directory. Okay, let me now Google that for a second. Seems I'm missing some syntax. Windows Python virtual environment. Okay, file. Scripts activate bat. So it seems like it's source without git bash unit. Oh, okay, yeah. Oh, sure. Source. Scripts activate. Let me just try this. Okay, scripts. And okay, it's still not doing scripts. It's spelled incorrectly. Scripts. Okay, cool. Okay, sure. Now I want to use one way, but I remember in the past I've done this. Activate the PS1. Doesn't like it. Yeah, okay. Didn't like the file extension. Okay, cool. Anyway, okay. Um, yeah, okay, well here it calls the shell script. Yeah, I think it's the same actually. Yeah, whatever. Okay, deactivate. Okay. Okay, cool. So now I am in that virtual environment. So now we can say like pip install PyTest. So it's installing a bunch of crap. That's why I didn't want to like specifically do it for this one, but it's fine. Okay, perfect. So now I can like create a folder here. So I can say like tests. And then after that, I can say like test lookup or something. So test lookup py. And then I have here, and then dev, so test hi, hello world, and now I'm gonna run this thing. So hello world, and now I want to remember also like I sometimes I forget these commands. So PyTest, it started explanation. Okay, do I just run this? Let's see, PyTest. And yeah, okay, cool. Yeah, I mean, there's other like CLI arguments. Let me see, PyTest slash help dash dash help. Variable fixtures, environment variables, okay. Yep. It's a big library. Trace, run, fall, markers, fixtures, expression, usage, PyTest, file or directory. Okay, file or directory, and I think it's only run such which might be given substring expression, reporting, verbose, increase verbosity, okay. Collection. Okay. So I think, yeah, for now, this is all that we need. And I also will need a fixture. So let me see if there's something like fixture. No. Let me see. PyTest fixture order, which is this one. For example, fixture test can also only be affected by an out to use fixture. If that test is in the same scope. Okay, actually, no, I don't need a fixture, sorry. I can just create a different instance. Okay, so hello world. So our test passed. Okay, cool. So I'm gonna say clear. Okay. So we can say def. We can call this like test end to end. So we can do like an end-to-end test. And then we can say pass. So from import. So here it is from lookup import lookup. And maybe we can like do some of this stuff, like an end-to-end test here. Okay, so I'm gonna just delete all these print statements. Okay. Okay, cool. So that's one end-to-end test. So let's run this. So by test. No module named lookup. And I actually, yeah, okay. No module not found there, no module named lookup. Well, I don't know if actually there's. So init py and okay, cool. So init.py, here I go. Okay, nice. So clear. Okay. Okay, perfect. So I'm gonna remove this. And then after that, I can have another test like def test deletion. I can have here my lookup class again. And then after that, I can actually insert this as well. So insert 5, then insert 4. Or actually before this, I can say like the deletion lookup, and then I can say lookup dot delete, and the key, let's say that will be like 7. You have to assert this will be none. R equals, this will return. So let's run this. Okay, perfect. Of course, it returns none. And then after this, so test deletion when table is empty. Okay, so that's our first test. So let's write another method, def test deletion when table is not empty. So that's another case. So we are going to insert. So let's instantiate another lookup thing. So we insert 5, and then we can say, okay, we delete 5. We delete 5, and we would say like R equals true. R should return true. And then perfect. So this this is successful. And then after that, we can create another test specifically for this. So no. Okay. And then let's say after this, we delete again, and this should return false. This should also return false here. We try to delete the same item. So false. So let's run. Perfect. So this returns false. And then now let's delete like something that doesn't exist. Should also return false. Let's return false. Okay, awesome. Return false as well. So I think that is enough. Let me see. So now I think we need to also test this one when we are probing. So for that, table is not empty, and probing, but does not need to be done. So now I'm gonna say, okay, def test deletion when table is not empty and probing needs to be done. So for that, we will say, okay, this guy here. So insert. And after this, we're gonna say insert 11. And we're gonna say insert, I think 10. So now I wanna print actually. So print lookup. And I wanna see if variables lets me do that. Okay, I'm just gonna search that really quick. So PyTest show print values. How to see normal print output creating during PyTest run. Disables per test capture, only if it test fails. Does it capture? No. Sometimes, okay. Using logging, what is this? How old is this? 11 years ago. Well, I'm gonna try it and see. Oh yeah, sure. Lookup the buckets, but I should just say lookup the buckets actually. I want to see now. Okay, yeah, it worked, but it seems truncated. Three. So it's 1, 2, 3. Okay, 11, 10, and now 3. So now we have to insert 3. So 3. Oh, okay, cool. So 3 is here. So 3, that's what we simulated before, should be here. 0, 1, 2, 3. And okay, so wait a minute. Actually, I'm gonna put here 4. So it's at the end, and then 3. 3. So yeah, 4 is here. And then 3 is gonna be here. Okay, so now I'm gonna have 3. And then 3 is here. Perfect. And now I'm gonna delete 3. So lookup dot insert. Oops, sorry, delete. Gonna be 3. And say R. R is going to be true. And then, oops, I want to delete as well this thing. So, I mean, print it. And here we have 3 is deleted equals true. Perfect. Awesome. So this is working. And now I am going to say, okay, def test search when table is empty. And actually, I think this is a good time to commit, in fact. So Okay, I can say like git add, yeah, git add. Okay, so the first commit is that finalized v2 implementation using double hashing for collision resolution. Okay, and the second is installed PyTest and added initial unit tests. Okay, so that's the commit. And then I can commit everything, push. Okay, perfect. So that's it. So pushed. So test search when table is empty. So the table will be empty here. And then of course, look up, oops, look up dot search. And this should return none, right? So R equals or R is none. That's the other clear as well, clear the thing. Okay, perfect. So it passes. I can actually also delete this. I don't need it. So okay. So the other thing I can do is dev. So test search when table is not empty. So let me see. I can do this, and then I will search 5. So let's say this will search 5, and R is not none. So we can run it again. Okay, perfect. And then, for example, here we can do search something else, like search 6, and R is none. Actually, wait a minute. I am doing some stupid crap. I think I have to also use the assert, actually. By text. Yes, I'm pretty sure. So assert, yeah, of course. Oh my God, no wonder. Okay. So I have to say assert. Yeah, I forgot that detail. Assert. R is true. Okay, perfect. So I have to go like this, is none, was equal true, okay. And R is not none, and then R is none. R is none. Okay, so here assert is fine. Da, 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 perfect. So here I have to do the same. So assert R is false. And then assert R true. Actually, this should be equal. And then copy this thing here. Okay, I think it's all covered here. So let's run again. Hopefully everything should pass. Yep. Okay, perfect. Now where was I? So yeah, test when table is search. The table is not empty. In search. Okay, perfect. And probing. Of course, this has to be renamed. So search when table is not empty. And probing does not need to be done. Needs to be done. So I'm gonna do the same here. I'm gonna recycle these guys. So I'm gonna recycle these guys here. 5, 11, 9. And of course, I'm gonna search for element 3. So lookup dot search element 3, and that needs to be like A. But I'm just gonna add this as BB here. So result. So first of all, so assert R is not none, and then assert R equals BB. That's the value we need. Okay. And that is correct. So I believe these are all the tests that are needed. Would also be very interesting right now. Would also be extremely interesting at the moment to see how I can stress test this thing. Although I don't have the resize implementation at the moment. But I can do basically, okay, let's do a simple, I'm gonna do a simple resizing implementation at the moment. So I think the way I'm gonna do this, okay, so I'm gonna have like def compute load factor. This. Okay. Character could be confused with an ASCII character. A, which is more common in source code. Okay, well, fine. So just delete that. Delete with it. Okay. Load factor, perfect. So return self dot size divided by m self dot length. Self dot length. So that's the load factor. I mean, kind of overkill to just wrap it in a method, but let's just do it like that for now. Let's do it. Let's do it like this for the time being. Okay, so whenever we are inserting, I believe this needs to be done. Oh my God, that is that is Siri talking to me. Anyway, let's ignore her.
Okay, I found this on the web for no one. Check it out.
Okay. When should we always start to compute this? I mean, inserting, searching. Okay, I'm gonna remove this time being. I don't know actually. And also Actually, length should always be a prime number as well. Oh, the thing is that it's quite expensive to everything, but I think, okay, let's just do this. So I'm gonna say new new buckets, and then I believe we need to say so that length we can do double the size for now. And I think I need to loop, so we're gonna say for item in of the buckets. And we're gonna say, okay, if item is none, I will ignore, continue. Actually, I don't want to make this, it'd be nice to test, but okay. If item is not continue. And then we need to recompute the hash function. So we're gonna say or actually, you know what? Just say this. Let me just reuse this variable here. And I'm gonna just put here n new buckets, Then we need to rehash. So it's gonna be, yeah, you can imagine like this. The way I'm doing this is very expensive. If we have like so many, like let's say, I don't know, 2 million items or something. But there's another stuff called like the dynamic resizing and everything, but I haven't like studied it yet. So I'm gonna leave this for the final section, final video. So I need to rehash. So I'm gonna say, so we are gonna say location equals self.hash. Oops. And then I need to reinsert this. Okay. Let's see. I think it should be item dot key. And then this should be 0. But there could there be collisions? I don't think so. I don't think there could ever be collisions when we are resizing. No, I don't think so. I don't think so, but that's an assumption. I'll have to test that. But okay, so we have the new location. So we are going to say location, and then we're gonna say equals item. We add it to the new location. But of course, there's something I want to just do here, but location is none. So location, oops, sorry, not this. This should be here. Assert is none. I'm just gonna leave that for now. To do remove. Okay, so new buckets. So I think that's it. And then at the end, we're gonna say, of course, self.buckets equals new buckets. And then you can imagine like the whole, you know, like garbage collection and Python will, yeah, it'll be, yeah, probably quite costly if this is huge, because we'll have like lots of pointers floating around in the heap that are no longer needed once we basically do this, reassign it. But anyway, I'm gonna keep it like that. But I think this should be finished. Yeah, this simple implementation. So B1 and then needs optimization. Okay, so okay. So I think this is it. So maybe this makes sense. Again, maybe like doing a method is like kind of overkill, but could be good as well with comments. So just to put a comment. So it's best to no. Okay, let me just okay. I'll try to. So okay, insert. So we say is self dot compute load factor, and we say here load factor quote. Okay, so load factor here. So okay, I think yeah, it makes sense to call it here. So if load factor, okay, let's put like some constant here. So load factor threshold 0.75. So if load factor is larger than 0.75, it's larger or equal, even like 70% perhaps, then we will resize. So self dot resize. Oh, and there's another thing, I believe, because we don't want to like put the deleted elements here in the resize. Okay. Or dot is deleted. We want to not, of course, because that will be ridiculous. So, okay, I kind of not, yeah. So, or I think there was some ways of testing private methods. Let me see. So Python or PyTest, test private methods. Erasure test duplication tests that look very similar by testing private methods. It has major consequences. Yeah, that's true. Let me see something here. My question is, how can I test? Well, my first secret, maybe don't use that form of private methods, so it's easier to do things like testing if instead you need to like. Test should be allowed to reach into. Well, okay. Yeah, I don't really need to test this specifically, but only test the insert here. Okay, so where is insertion? Test, search, test end-to-end. The search, test end-to-end. Okay, so I'm gonna say now test def test insertion when resizing is not needed. Okay, so say this. Okay, so let's run. Failed test. Oh yeah, collision count. So I thought collision count. Okay, I should have this as an optional variable. So 0 first. Okay, it's failing. Why? Oh, I know why. Load factor. Okay, this broke everything. Of course. Okay, let me just. Yeah, cool. Okay, so this broke everything. I wonder why. So let me just print load factor here. So load factor, so here. Let me just okay, just delete these guys. So Python main.py. So load factor is 0,0. Okay. Of course, I will fill up here. So let's see what's wrong with this. Let's see what's wrong with this. There's a bug in the resize. Resize, yeah. So assertion error. Assert new bucket's location is none. So it seems there is a hash collision coming here. Assert 6 equals 5. You know what? Let me just go like this. Just for that. Just want to test it. So test end to end. Okay, so okay, definitely the resizing method is failing. Let me just comment all this out for now. Comment this out. And let me just go like this. Okay, so load factor 0.4. Then 0.6. This one will be 0.8. Okay. So I want to print. So print. Lookup.buckets. And here I also want to print lookup.buckets. It should be resize. So here we have none, none, none. So it's resizing as expected. So hash So we'll have different hashes, of course, because it's a new modulo. Okay, and now I want to, what happens? I want to see, okay, let's keep moving these guys, so. Okay, so this is the problem. Oh, no, of course, lookup size. I see, yeah, of course, lookup size is, this has to be 6 now. Because, yeah, okay, because it's resizing. So, yeah. But actually this has to be lookup that length. We also need to test that. So lookup that length. Okay, cool, yeah. So unit tests needed to be updated. So we have to say lookup that size is this, and we also need to assert lookup that length equals 10 because it was resized. Okay, yeah. This we also I also need to update this because length. So when resize, I need to say self dot length equals length of the new buckets, or I can just say n actually. Okay, perfect. All right, load factor. Okay. Okay, perfect. So I'm gonna do it again. Okay, so this is working. I'm gonna make a comment here. So here this was done. Okay. So now let's uncomment these guys. So let's uncomment these guys and then this should work. Haha. Ah, interesting. So let's see which one is failing actually. Okay. Search. So for some reason is not being able to search 5. Let me print. Let me see. Key 11, key 0, key 3. What happened with 5? Huh. Interesting. Seems like 5 disappeared. Key 10, key 11, key 0, key 3, key 4. Where is key 5? Let me see. Okay. I'm gonna remove this thing. So it seems like 5 here is disappearing. So let me see why. Mm, okay. Hmm. This is strange. Okay, let me see. What is happening to 5 here? What is happening? So 5 seems that it's the only. Five is not getting passed to the new. Let me see. None. Hmm. Self the buckets. I want to put here self the buckets. Hmm. Okay. 5. So 11, 10, 5, 4, 5, 11, 10, 4. Yeah, I think, okay. Just trying to think out loud. So, okay, that passed. Um, and actually, delete, insert. Oh, I'm just gonna print this thing here. And okay. Failing. Load factor 0.8. Let me remove this. Okay, 0.8. So this insert 3. Aha, size. So size, I need to recalculate the size as well and resize. So have to say self dot size equals 0 as well. I just want to, well, that's not the reason why this is not working, but I have to update that as well. Plus equals 1. That's, oh shit. That's one thing. Okay, so when resizing is done here, need to, okay. And I still want to print this guy here, so look up the buckets to see what's the output. 10, 11, 0, 3, 4. 10, 11, 3, 4. And then what happened to 5? That's my biggest question. What's happened? What is happening to 5? And I'm wondering, I think it's, yeah, I think it's just because there's a collision here. So 0, yeah, so it's, of course, it's because there's collision. So there, we need to handle those collisions. Needs to have like an insert, another insert here. So well, actually, I need to do this. So self.insert, self.insert and item.key and item.value. That's what has to happen. And this will internally handle the collisions. And then of course, the thing is this one. The thing is this will, of course, throw. But size here will be 0. And then n. So we have to just say this actually. So self.length actually will equal this. So self.length will equal this, and then here it's self.length. So it's reset. Boom, and then we have this one, okay. And this one out. Then we insert. This will become this, okay. So let me, okay, I think that should be it. So now index out of range. Index out of range. Self.buckets, of course. Yeah, this will not work actually. No, 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 no. So I have to either I remove this from here. Yeah, so it seems this kind of not intuitive at all. This is not intuitive at all. So insert in. Actually, I mean, one easy solution could be doing like insert. Perhaps we can do resize. And can this, so we have can do something like this. Or self, and then I can say this guy here, and then I can have this thing here. Here, and then I can call insert here. I can call insert. Wait a minute. Okay. Okay. So I can call, let me see, insert. Insert here, actually, insert. Where no resize is needed, and then insert. Okay, so that inserts. Okay, let me test this. Yeah, sure. The in value still out of range. Fuck, why? So then insert item key value. Where I want to see where the hell. Yeah, so it's still a new. Yeah, it has to be. Yeah, I think. Okay, I see. I think. Well, yeah, this is the deal here. I mean, I'm kind of tempted to do something like this, actually. Have this outside, like an outside external module or external method here. An external method. And then I, instead of self, I'm gonna say like table lookup. And then something like this, although this one will be private. So rename some symbol hash and say that it's I think this should work. Or the idea is buckets actually. It should be passed as reference. these buckets things. So table. Okay. So insert. Buckets. This is kind of weird actually. Say new buckets. New buckets and then key and item. Although I think this is kind of weird. Then item dot key. So I'm gonna try to do this and see what happens. I think lookup object does not lookup inserts. Here. So yeah, again, self, and I will have and then self dot buckets. Lookup insert is not defined. Where is this? Name error insert if look why does it say it's not defined? What is this? Let me see. No, I'm gonna delete this thing here. See if it runs. Yeah, what's up with this? Yeah, you know what? I'm gonna delete this crap. Maybe won't like this because of this. But now, what's up with this? Now it's complaining. One, two, three, four, and five. Okay. So now I want to print this thing. Lookup dot size. Why is it 9? So lookup load factor is 9. With resized. Okay, so let me see. It's probably resizing here. Um, so I'm wondering why the fuck this is 9. Mhm. Okay. So. Oh my God, this is really annoying actually. So it's gonna be size. So it got size. Okay, so that size, let's run this. So size is 8. And then after that is 9 because it's resized. Okay, so sure. Okay, fine. Fine, fine, fine. Fine. Do it. Yeah. Go here. Okay, sure, fine. Oh my God. 1, 2, 3, 4. So 1, 2, 3, 4, and 5. But 5 should, lookup size should still be 5. Not 9. So let me just print this thing and see. 1, 2, 3, 4. Why is size 8? That's the thing I don't understand. Oh my God, yeah. Let's be no new brackets. And then we have table that hash. I think we should also have like the hash key here. So I think we should have the actually here, I think it should be hash because this is problematic. Non-provision count. Yeah, no. So I think, yeah, I think the problem basically here is that then we compute the hash, but it still has, is it? Table size plus 1. Yeah, so I think this shouldn't be here because we're doing here in the insert, so that's why. Okay, yeah, size is 4 here. Okay. So size should be 5. Okay, cool. So this is fine. Size should be 5. Okay, perfect. So 6 and then length. Length should be 9 or 10, sorry. So let me just length. So this should be 6. No, this should be 6. Yeah. 1, 2, 3, 4, 5. And then this should be. Okay, yes, length should be 10. Perfect. Now I'm gonna do this. So insert. Okay, perfect. Now you should run all grid. Okay, fine, cool. They run. Perfect. Okay, nice. So this, of course, was a bug. Okay, so there is collision. Okay, cool. There's one thing I don't really like is this insert thing flying around. Okay, let me now start uncommenting this stuff. Okay, so this, when resizing is not needed, so of course, resizing here is needed. So I'm gonna, okay, just before insertion, let me just keep running these tests as default, okay. Okay, so let's run. Perfect. Let's run this thing. Okay, perfect. Perfect. And perfect. Okay. So test deletion, 1, 2, 3, 4. So this is working here, which is good because we resize and then we delete. Now we say, okay. So let's just run this guy. And then I'm gonna say, create this one when resizing is needed. This is, of course, is tested here, but I can recycle this one. Here, resize, was done. Okay. So let's run everything. Okay, cool. So now this load factor crap, I need to delete it from here. So load factor. And I'm wondering actually, there's one thing. I mean, there's one thing I don't really like, which is taking this insert thing apart here. But that's more like of a design thing. Yeah, I don't like it at all. But what happens if I do, I mean, if I bring it here and I say, if I say, for example, here will be bucket data or none. What happens if I just do this? So here, see, so this is buckets. So the buckets is here. Mm, I have here key and value. So let me run everything. And yes, that's a little better than having this thing just flying around here. Yeah, so I'm more happy with this one. So I'm just gonna leave it like this. Thing for now, for the time being. This thing as well. And let's run all the tests again. Okay, so everything is looking good. Everything is looking good. Now, an interesting thing will be to stress test this thing. So it would be nice to like generate like a bunch of like random thing, like a million of like insert delete. So I think, let me see if I can stress test this thing. I'm gonna use, okay, little perplexity. So please generate a random sequence of, please generate a list, a Python list, or what could be better? Okay, yeah, please generate a sequence of random strings where each string contains the words insert, search, or delete. Come on. No, it didn't get the thing. Okay, so let me see. Okay, please generate a sequence of random strings of random, let's say word, where each word equals the sequence should contain total of 500 elements. Oh, or delete. Come on, it's taking such a long time. Let me refresh. Come on. The sequence should have 500 elements. Come on. Like breaking. I just think I don't want to write a Python code for this. Okay. It breaks. Okay, fine. Let's try. There it is. Fuck. Insert, search, delete, insert, search, delete. But it's not mixing them. Oh my God. Okay. Seems like I have to do this manually. So Python generate random floats. Okay, let's see uniform. Fine, let's do this crap. So import random, So let's go to main.py. So import random. Okay. So uniform. So we say R. So we're gonna go if R is larger than 0.8. We will say so actions dot append insert. If R is smaller than equal to 20, 0.20, we will say actions dot append let's say 15. We will say delete. Otherwise, elif, and then we're gonna say otherwise, like okay, actions dot append. We will say search. Okay, so here we have actions, and we're gonna say for just say okay, I don't know, 1000. And one thing I want to do here is okay, print actions. Oops, Python main.py. Okay, so these are random insert, delete, search, delete, insert, search, insert. Okay, perfect. That's what I wanted. Okay, so now let's do this thing. Let's do this, baby. So, okay, so I'm just gonna create a method called like def stress test. And let's put size. So let's default to 1000. And we are going to have this thing here. And after that, I am going to create lookup. And then here it's going to be size. And after that, I'm going to loop. So for action in actions. Whoops. For action in actions, lookup if action equals insert, we can say lookup dot insert. Okay. And that's the thing now. P. Okay, so random. I'm just gonna generate some random stuff as well. So random. Let me see what I can do. Random dot. Is it? Is it range? Choose a random item from a range. Oh, let's see. I forgot. Random. Let's see. Python rand int. So rand int between, we can say 0 to, I don't know, size times 3 or times 2 times 3. So we can say key, and we can say, okay, sure. So this is the key. We just can put the same value. So yeah, whatever. Okay. Action delete. We can say lookup dot delete, and we can just say, have the same key here. We can delete the key. Else lookup dot search for the key. Okay, cool. So let's do that and see what happens. So stress test. Let's keep it here. When I run clear Python.main, and it runs. It runs perfect. So I don't know. I'm gonna bump this up like 5,000 and see. It's one of prints as well. Oh. Yeah. So okay, let's see. So lookup dot size. Total items. And now we can say total lots. Buckets. Total buckets. Oops, I said length, sorry. Yeah, so total items 1,957. I'm wondering if what happens if like the size is like much larger. $40,000. And it resized initially, of course. Um, so actually size, and then I want to put also like operation count. So operation or action count, action count. Let's just actually, okay. Maybe 10,000. Let's put 10,000. So a maximum of 10,000 elements, or no, that's like initially. Let's say 500 initially. And the action count. Let's say if we have like 1,000,000 operations. So we have 4, 5, 6. So 1,000,000. 1,000,000 operations. So yeah. Right side. Okay, let's see. I mean, this is also gonna take probably quite a long time doing this. So maybe that's also a lot to do in memory. Like this list will be huge as well. So maybe one thing. I want to create actually maybe a generator. Okay, let me just copy paste this really quick. I want to use perplexity, so please create a generator from the following Python code. Let me see. Yeah. Okay, let's copy this one. Python generator. And that's how it says. Python generator. Okay. So just say like this, 1000. Yeah, this is still working through it. So, okay, that's our actions. And I'm wondering if I don't need a list per se. I see if this is possible here, which I think it is. So let's do this Python generator. So we have actions, even, and list of actions. Let's say like 400, 100 here. Okay, so let's do this, burn. Okay, perfect, yeah. Insert, insert, search, search. Okay, so this is working. So let's do it here. And after that, let's print these guys. And we'll just say print, and we say action. And delete this, I'll comment it out. And okay, cool, delete, search, search, delete, okay. I think that will be a little less memory stress for the system with this generator. Okay. Over 1000. Okay, perfect. And 5000 as well. 10,000 actions. So let's go over 10,000. 10,000. So let's actions. Action. And then this one will be table size. We can say 500. Yeah. Now let's do it. Okay, perfect. So now instead of 10,000, let's try 200,000. Ah, crap. Come on. And taking some time, and I'm pretty sure that's maybe because of the delete of the insert of the resizing, probably. So we have 50,000 items and 128,000 available slots. Yeah, I mean, also let's see how is the correct way. So Python, then Mark. So let's see, time it. Look at time it by the profile. Make sure to have a look at the comment below. Engineering snake piece gives you yet another visualization of profiling data. No, but I don't want that. There was something else that I used before, but I don't remember. Python. Benchmark. Let's take a look at this now. It's still a timing thing. How long it takes to some code. Let's see this one. Still time it. I don't want to use time it actually. Yeah, I don't want to use that one. Python, delta time. Simple way, benchmark code. Still this one. Okay, well, I'm gonna actually leave that for later because also this thing is taking a long time. This video. So I'm gonna commit here. So the two things that were done, which were implemented resize logic v1 or implemented v1 resize logic dated unit tests. And the last thing is that added stress test method in main.py. And then git push to master. Okay, so yeah, this is it. So I think this is yeah, nearly finished. Just maybe a couple of things like benchmarking the performance as well of the resize, but we know it's basically very inefficient. Because then we will have to do that like, it's gonna be linear time basically. So, and then another challenge is that we can't do that while another operation is happening. Like if we're thinking to making this like a cache, for example, like, you know, there's gonna be different concurrent requests. Also how all this implementation manages concurrency. Yeah, I'm not really sure, but let's see. Maybe I can do here like to do. And so how does it handle concurrency? How does it handle concurrency? Improve resize logic. So those are, I think, the two major things. How does it handle concurrency and improve resize logic? And as well, after that, we have to turn it basically maybe turn it into a cache, but I'm still not sure. I mean, this is not really, yeah. I mean, there's not gonna really be an order of priority. We can say turn into cache. And then I think what I would really do is like make a Go version as well. Would be interesting. Okay, so I think that's what's left on this thing. So I think that is all for now.